Okay, you're right. But like,
he's technically a teacher.
He's being reading. She's being wrong.
Hi, Small.
Right by your right foot. No. Yep.
Something
I'm reading wrong, like,
that can cause
something like that.
All right. Let's change topics. We're going to shift from that conversation up here to this. Not saying it's not an important conversation to have. I just don't know it's an important conversation to have at 7:15.
It's too early for any conversation.
It is a lot early for a lot of conversation. Unfortunately, y'all got assigned the 7:15 math class and you stuck with me. So, mwahahaha.
I just hope I did this right.
Let's go for it. So I highly recommend that we switch it to vertex form. That's exactly what we did yesterday. So first thing I'm going to do is I'm going to get that axis of symmetry. This pen seems chunky. It's not. It feels chunky. It does. It's the same exact setting I was using yesterday, but it looks chunky. That feels better.
Might
But
be the
it's.
color that you're using.
I use the same one. I don't know. It's just being weird. Dude. Hip check the tickle.
You okay?
I'm fine. Haven't had enough coffee yet.
Felt.
All right, so we're going to find our axis of symmetry. That's when we use our opposite of b over 2 times a. So our x equals, what is the opposite of our b? 2, because our b is negative 2, so the opposite of b is a positive 2. Over 2 times a, what's our a? 1. So 2 times 1 is 2. So our axis of symmetry is going to be at x equals 2 over 2, which is 1. So that tells me in my vertex, the x value is 1. To find our y value, we substitute it in. We're going to take our f of x, which is our y. We're going to substitute 1 in place of the x. That's what this is. Now, I wouldn't use this notation a bunch in here, but that's what they're doing. We're substituting 1 in place of the x. So we're going to have our 1 squared minus 2 times 1 minus 3, which we can type in the calculator, or we can do by hand, because this one's not hard. 1 squared is 1. 2 times 1 is 2. Minus 3. So 1 minus 2 minus 3, negative 4. So our vertex is happening at the point 1, negative 4. 1, 2, 3, 4. Boop. So I've got that point. That'll also give me my vertex form where we can write this as y equals our a, that same a that we used in here to make my denominator. We've got that 1, x minus h, which is 1 squared, plus k, plus negative 4, or minus 4. So I've got my vertex. From my vertex form, we got it from our axis of symmetry. We wrote it in the equation. All we got to do now is fill in our table. Our vertex goes in the middle. That's our 1, negative 4. I need some numbers that are smaller, like 0 and negative 1. I need some numbers that are bigger, like 2 and 3. So this is how we started the chapter. So it's been a good solid week and a half since we've done this. So this is our vertex. That always goes in the middle. When we set it up with our vertex in the middle, that means we have matchiness going outwards. So we don't have to put in every single one of these values. You can, totally works. Yeah, we also have our shortcut answer because when we have an x of 0, the y is going to be this constant at the end. So I know that for 0, we're going to have our minus 3, which means because my vertex is in the middle, this guy's also minus 3. I can put those points down here. 0, negative 3. 2, negative 3. And then all we've got to do is type in our negative 1 or the 3. And again, they should match up because we set this up with our vertex in the middle. So when you substitute in negative 1 or when you substitute in 3, either way, we should get 0 as our answer, which means we have a 0 as our answer here, which means I know where my intercepts are. Oh, snap. We've got 1 here and 1 here. That is enough information to give me a graph. You do need to have several points. You cannot give me 2 roots and a graph. That's not enough information. You cannot give me a vertex alone and a graph. You have got to give me several points. Ideally 5 points or more. But do not just give me a vertex in a swoop and call it good. No. More information. Okay. Questions on the graphing part? Because we've done it, but it's been ages. Like, we did that back in October, technically. Okay. Because what we're going to do today, it does not involve graphing, even a little bit. I'm going to start with a thing for you guys to hand out, like, so that you don't have to write the whole thing down. I'm going to put a table up, and in fact, I'm only going to put half of a table up, because it's a long table. But I printed it out for you guys so that you guys can look at it and not have to try and speed write the whole thing down because it's a little complicated the way it says things. But what we're going to do today is we're going to talk about something called the discriminant, which is a part of the quadratic formula, which is one of those like big things that is one of the things that people remember for like the rest of their lives when they have those random pieces of math that can't get out of their brain, like y equals mx plus b. Like that sticks in people's heads. That's the thing they remember. Well, for algebra 2, it's the quadratic formula. We're going to talk about the full quadratic formula tomorrow, but this is an important piece of it. And it's a piece called the discriminant, which you have worked with several times before. So inside the quadratic formula is the discriminant. Yeah, that's what you're passing. And the discriminant is this shockingly familiar expression here that we have used in bell work repeatedly. We've had it show up as review questions repeatedly. We've had it show up on homeworks as questions repeatedly. We've seen this guy before. That random expression that I have you substitute values in to find a number. That guy's called the discriminant. And what that can do is actually tell us how many and what kind of roots we're going to have from any quadratic ever. Who was it that asked for this? Okay. I was going to say, I was like, I grabbed it, I grabbed the pen, and then I went, I don't remember. All right, so we have this table, and what we do is we look at our standard form equation. So that's what the top says right here. This is the top of your table. Looking at our standard form expression, the rest of it just means a is not 0, and we don't have weirdness, like it's numbers. And if this discriminant, the value of that expression, if it is a positive number, we're going to have real answers. Like, we're going to be able to point to them. It crosses the x-axis. So if we have a positive discriminant, we get 2 real roots. Both of these boxes actually say that. The only difference between these first 2 pieces is if we have a perfect square, so 1, 4, 16, 9, 25, 36, 49, those guys, perfect squares. Then we're going to wind up with a rational root, a number that we know, like usually an integer, like 3, 4, a number. If we get anything other than a perfect square, anything else, we're going to wind up with an irrational root, like 2 plus the square root of 7, 3 minus the square root of 12. Those are our irrational roots. Either way, we have real roots, and honestly, the real is the most important part here. Rational and irrational is great, but real is the most important part. If we have a positive discriminant, we have 2 real roots. What that means is if I was to graph, that is not a pen. If I was to graph the parabola, like we did in the bell work, if we have a perfect square as our discriminant, our parabola will cross at pretty numbers, like -2. Could be fractions. Maybe it's 3/2. Those are fine. They're integers. Or they're made from integers. They're rational. If we have irrational roots, that's when we graph this. And we could have upside downies. Like we could have, they don't have to be right side up. But they're going to be something ucky, like 2 plus the square root of 6. And 2 minus the square root of 6. So, but they cross the x-axis. They're real. I can point to them. I have 2 solutions. I've got one here. I've got one there. I've got one here. I've got one there. I have 2 real roots. So the 2 real roots is the most important part there. So if our discriminant is positive, we have 2 real roots. They might be rational, they might be irrational, but we have 2 real roots. The next part of the table, which I just put on the next page because otherwise it was microscopic. The next row down has if my b squared minus 4ac, that discriminant, equals exactly 0. Not 0.1, not -1, not close to 0, 0. It's 0, the only option. That means we have 1 root, 1 real, and it will be rational, 1 real root. And what this looks like when we graph it is a parabola that actually just bounces off our x-axis. We only have 1 root. That guy. It'll also be our vertex every time. So if we have a discriminant of 0, our vertex is our root. And then our last options we've had if that statement is positive, if that statement is 0, or if my b squared minus 4ac is less than 0. So if we get a negative number, that's when we get complex roots or imaginary roots. Complex numbers are just those, like the 2 plus 3i. That's what that is. So when it says complex root, that just means there's an I in it somewhere. So this would be our imaginary. And sometimes we call this no real roots. So we can word it any way we want to. But all that means, remember, our roots are also our solutions, our zeros, our x-intercepts. So this has no x-intercepts. It has no roots. It doesn't hit our x-axis at all. That's when we wind up with our imaginary roots or our complex roots. And we've seen those a little bit, especially when we've solved using our square root property. We've seen our imaginary roots pop back in. But most of the time when we have imaginary roots, we're going to use our quadratic formula, which we're going to only do a piece of today. We'll do the whole thing tomorrow. But I didn't want us to have to try and speed write these down. Because what we're going to do is we are going to be given an equation. And I'm going to ask you, first things first, is how many and what kind of roots do we have? That's what we're going to look at today. So that means we're going to find our a, b, and c from our standard form equation, and we're going to put them through our discriminant, this b squared minus 4ac. That will be one of those, like, I will show you where that is in the formula that we use that is given to us on the test. Like, we will have it. You do not need to memorize it. You might, just because we're going to use it a bunch, but... The sign is by your eyeballs. But if you stand at the sign like this, it's just weird. What's up? For the restroom? Okay, give me a second. So here we're given a quadratic. We're going to describe, the way these problems are worded is often describe the number and type of roots. So the first thing we need to do is we need to figure out what is our A, our B, and our C. We did this yesterday when we were switching them into vertex form because I wanted us to practice this before we got to today. So first thing I want to know is what is my A? 2. What is the B? -10. And what is C? 7. Because we match this up with our ax squared plus bx plus c. That's where those numbers are coming from. We're using our standard form equation to get us there. So then what we're going to do is we're going to substitute those into our discriminant, which I do have on the top right for us over there. So I'm going to take my b squared, so I'm going to have my -10 squared minus 4 times the a times the c. And we're substituting all those values in. And if we're careful and we use our parentheses, you can type that statement into the calculator as it is, but you got to use the parentheses. Super important because -10 squared gives me positive 100. 4 times 2 times 7. It's minus 56 here. When in doubt, do your multiplication in pieces. You can either do 2 times 7 to make 14 to do times 4, or you could do 4 times 2, which is 8, 8 times 7. Sometimes we're a little more comfortable with that than doing 14s. So 100 minus 56 is going to be what?
44.
44. So the value of our discriminant, that's what this is called, the value of the discriminant I hate writing it out, is 44, which sometimes we will ask you that and just like give you a blank. What is the value of your discriminant? 44. Is that positive, negative, or 0?
Positive.
Positive. Huh? Yeah, that's positive. Definitely positive. So if it is positive as a discriminant, does that mean we have real roots, imaginary roots, or so 2 real roots, 1 real root, or an imaginary root? 2 real roots. So since we have a positive discriminant, we know we have 2 real roots. Is 44 a perfect square? No. We know 36 is a perfect square, and I know the next one up is 49, because 6 squared is 36, and 7 squared is 49. So 44 is not a perfect square. So these are going to be irrational. We're going to have square roots somewhere. And at this point, this is all we can do with this. We're going to have 2 real roots, and they're going to be icky decimals. That's what we know. Okay, questions on this one? We're going to practice this a couple of times. The number of roots we have is 2 real roots, because we were asked what kind and how many. So 2 real is our how many. Irrational is our what kind. So 2 real irrational roots is our answer here. At this point, we don't have the information to actually get to the roots. We'll do that tomorrow. We're just kind of breaking this into pieces, because the formula is obnoxiously long. But we give it to you. You don't have to memorize it. Like back in the day. Oh no, 100% I learned it in 8th grade, and we marched around our school chanting it like a creepy little math cult.
Why?
It was a very small school. We marched past the kindergarten room chanting the quadratic formula.
The poor kindergartners.
Welcome to the 90s. Just saying. Yes, I was in 8th grade in the 90s. And now. All right. So the same kind of vibe. Same kind of vibe. We are going to find our A, our B, and our C. We're going to run it through our discriminant to see what kind and how many roots we're going to have. So the first thing I need to know is I need to know what is wrong with that pen. What is A, what is B, and what is C? So what is our A on this one?
-5.
-5. What is our B on this one? 10. What is our C on this one? -15. We're going to substitute that into our discriminant, that B squared minus 4AC. That is called the discriminant. That's its name. It's like calling it Bob. It's just called the discriminant. So we're going to substitute this into our B squared minus 4AC. Just make sure we use parentheses when we substitute stuff in. We're going to have our 10 squared minus 4 times -5 times -15. So our 10 squared, that's going to give us 100. Minus 4 times -5 times -15. Yeah. That is -300. So these two minus signs have canceled out. So we're going to have a minus. This value is 300. Be super careful with our signs here. That is the biggest place that these will catch you. So 100 minus 300 is what? -200. So the value of our discriminant, if we're asked for the value of our discriminant, that's our guy right there, -200. That is the value of our discriminant. An important number to have. We're going to use it tomorrow. But what does that tell us?
It's a negative number.
It's a negative number.
And that means it's, I don't know, I wasn't in here, but it's one of those things.
It's one of those things.
That we were just talking about.
Sure is. Our negative roots, or our negative discriminant means, are we going to have positive, or are we going to have real roots or imaginary roots? Imaginary roots. When we have a negative number, that means we have 2 Imaginary, and I don't care if you say imaginary or if you say complex. Technically, they are complex roots, but if you say imaginary, it's the same exact vibe. There's going to be an I in there somewhere. I'll write both. So if we have a negative number, we get imaginary roots. If we have a negative discriminant, we will have complex roots. I genuinely do not care if you say imaginary or complex, whichever one works better for your brain. Technically, complex is righter, but I will 100% take imaginary. 100%. And at this point, that's all we have for this. It is just how many and what type. We're going to get 2 complex roots. This is the answer to the question we have here at this point.
How do you know how many it is?
That little table that you got, you got one of these.
Yeah.
If the discriminant is positive, that's what these roots are. We have 2 real roots.
Okay.
If it equals 0, we have 1 no root. And if it is less than 0, meaning it's negative, that's when we have our 2 complex roots. Okay? So that's giving you the things. The only thing that we put in that right side was a little sketch, and I can put it back on that. I know. It says knock like you mean it, because otherwise people just go up and walk by the door and they just stand there.
Mm-hmm.
And then it gets a little creepy.
It gets real creepy.
Because you just glance up and suddenly there's a face.
Mm-hmm.
All right. We're going to do one more like this. We're going to figure out how many and what kind of roots. So that's what we're starting with on this. How many and what kind of roots?
Oh, yay. More problems. Yay.
I'm going to just say, dude, it's math class. What do you expect? Just say.
Yes.
All right. So first thing I need is I need to know what's my A, my B, and my C. I do want us to write those out because we're going to need them tomorrow. Like, I want us to have A equals B equals C equals. We're going to use them. I don't just do it for this problem. Like, we need it for lots of things here. So whenever we're going to work with this whole formula thing, I want us to have A equals B equals C equals. Write them out. Because what is our A? 2. It's the one in front of the x squared. What is our B? 8. And what is our C? 8. So we're going to use our discriminant. We're going to put it through that B squared minus 4AC, which I didn't get copied onto this slide, but I'll write it over here. Minus 4AC. So we're going to substitute our pieces in. We're going to have our 8 squared minus 4 times A, which is 2, times C, which is 8. We have worked this expression so many times. Should be vaguely familiar, hopefully. Because my 8 squared, that's going to give me 64. And 4 times 2 times 8.
Negative 64.
Yeah, we have minus 64. Because 4 times 2 gives me 8 times 8. So 64 minus 64. 0. So the value of my discriminant is 0. Which means what kind of root are we going to have? We're going to have one real root. Since our discriminant is 0, we're going to have one real root. That means our vertex is going to be our root. It's going to be rational. It's going to come down and bounce off my x-axis. It's not going to pass through and come back up somewhere else. The vertex is our intercept. That's what that tells us. Okay? We are going to use this a bunch tomorrow. because we're going to do the full quadratic formula tomorrow. Again, I'm not going to make you guys memorize it. It's like we're going to give it to you. You're welcome. If you're going to go into pre-cal, though, you might start working on memorizing it because you do need to have memorized pre-cal. There are lots of songs on YouTube that gets put to. Traditionally, it's like the Pop Goes the Weasel song. But there are so many. And if you ever run out of ideas of things to look for, they're so bad. They're so bad. But we're going to use the formula tomorrow, the full formula, and our discriminant is written in it, so I will show you where to find that. That will be given to us in the formulas on the test. We have 5 formulas I give. The last one is our quadratic formula. This is our last, formula. Okay? But that's it for today. Before I hand out homework 3-6, I'm going to give us a little word warning on it. The front side is what we're doing tomorrow. So you can absolutely do our discriminant on them, but do not take up the whole space because we're going to have another part of it to do tomorrow. We're going to need our discriminant for them, so if you want to do it and get kickstart on that, totally valid, totally fine. But we're going to have more things to do, so just don't take up the whole space for each problem. If you want to just do what we did today, the discriminant and number of roots, that's these guys right here. Okay? So the back is 100% what we did today, this guy and this guy. You can do the discriminant on the front. It's just we have more things to do tomorrow because we're going to get all the way down to what the roots are. So I'm going to pass them out just so you can have them. You guys can start on stuff. I lined up really badly. But you guys have the rest of the time today. If you guys have questions on stuff, we're working on all stuff. We've got questions on that. Totally fine. Everything as of yesterday, like that's been turned in as of yesterday, should be in Canvas and in Skyward. They're pulling progress report grades today. So check your stuff. Make sure it matches what you think it should be. Because they're pulling those grades today. For the last progress report of the semester.
Oh, God.
I know. But they're pulling those grades today. I try and make sure it's not a surprise. I don't ever want things to be surprises for you guys, not unless it's strategic. Or good. If it's a happy thing, I'll let it be a surprise.